Now, the fault in this circuit is so difficult that even if you replace all the parts of the board, you still cannot fix it. Even if you replace the microcontroller, you still cannot fix it. But as soon as I gave the electric supply, the indoor unit has turned on. Now, I will turn it on with the remote. As soon as I gave the electric supply, you can see here LED 1, 2, 3 of the outdoor have also turned on, and the indoor display has also turned on. Now, both PCBs are working, but still they are creating an issue. So let's see what issue is coming here. The fan motor has also started running, while its outdoor LED is continuously running here. Now, this display is showing error 36. The meaning of error code 36 is that the indoor and outdoor are not able to communicate with each other, because of which this issue is occurring. Even though, as you can see, I have made proper connections between the indoor and outdoor, there is no issue here at all, but still, error 36 is coming because often this problem is also caused by the wire connected here, while I have properly connected the wires here so that there is no issue with the wiring. Now, first of all, we will check the indoor. I will give it electric again. I turned on the electric, and this second pin is neutral. So I will place the black probe here, and I will check this red wire that we have. So here, as you can see, stable 25 DC volts are coming. So this means that the system is not working properly. It is not communicating. Its communication operating voltage is coming. We will have to see from which PCB these voltages are coming, because this depends on the design. So here we need to check whether the indoor is generating 25 DC volts, or the outdoor is generating it, or if both are generating it, or if one is generating less and the other is generating more. So for this, what we will do is disconnect this signal wire from one side, whether from the indoor or the outdoor. It's the same thing. So we have disconnected it. Now I will first check on the indoor side. I will connect the neutral with the black probe, and the red probe I will place on the signal, which is number 3. So here you can see 24.94 volts are coming. This means that the voltage is being generated from here, which is important for communication. Now, in the same way, I will check the outdoor as well. So we will place the black probe on neutral at terminal number 1, and we will check on number 3. So here you can see that no voltages are being generated at all. Even if we lift the probe, nothing happens. Only a few millivolts are coming, and the bars below are fluctuating. So now we will see whether the fault is in the indoor or in the outdoor. This also needs to be checked. First of all, we will test the indoor and the circuit installed here. You can see all of these are resistances, diodes, capacitors, ceramic capacitors, and here are these 2 optocouplers. Apart from this, you can see there is a PTC sensor installed here, and here as well, there is a resistance, which is also part of this circuit. Along with this, all these diodes and resistances installed here together are both receiving and sending the communication. Now, here we only have to check the communication of one side, because the receiving communication has already been removed, since the outdoor is not connected with it. So this optocoupler here, which is B904, we will not check this one. We will check only the B903 optocoupler, because it is the sender, meaning it sends the indoor signal towards the outdoor. So I will check whether it is sending signals or not. Its pin number 1 and 2 are the anode and cathode. So if signals are coming here, there is an emitting diode inside it which flashes, and by flashing, the transistor on pin 3 and 4 allows the voltage to pass from emitter to collector. And at the same frequency at which data is coming from the microcontroller to this optocoupler, at the same frequency the voltage then moves forward towards the outdoor. So for this, today I will use a DSO oscilloscope. For this, we need ground, so we will take the ground from here. You can see this is the fan, so I have installed the pin here on its pin number 3, the yellow pin. Now I will connect the ground pin of the oscilloscope here, and I have turned on the PCB. The PCB is now on. Then I will place it on pin number 2 and wait. So here you can see signals are being generated. So we will change its scale and make it a bit smaller. Now you can see it clearly. So here you can see all its details are appearing at this moment. This means that the indoor is properly sending out its signals. By checking it this way, we also found out that the indoor sends a hello signal first, and when it sends this hello signal, then the outdoor responds that it is present here and tells what operation it needs to perform. So here you can see there are 2 optocouplers installed. Along with them there is a complete circuit on the back. There is a PTC sensor, then resistances, some capacitors, diodes, and here as well there are resistances and diodes. So this whole setup is the outdoor communication circuit. The IC installed here, B902, receives the data, and the IC B901 sends the data towards the indoor. Now what we have to do is check whether the data is reaching here or not. So in this, you can see sensors are also installed. So I will place the probe on the sensor point for ground. I have taken the ground from here. Now I will turn on the PCB. Yes, the PCB is on. It is necessary to turn it on once with the remote. Now first of all, I will check on its anode, whether signals are coming here or not. Positive side. I have reset the oscilloscope. Here you can see it was set at 5 volts. And here around 160 volts are appearing. And the frequency is about 7.26 hertz. You can see it is around 50 hertz because the data comes intermittently. Now I will check whether this optocoupler is shifting the data forward or not, because that is very important to check. On the collector, there is no voltage present. The oscilloscope is completely silent. There is no output coming. So here, this optocoupler is not able to receive the signal. And because of this, the issue is occurring. Because when it receives the signal, then its output from the optocoupler goes towards the outdoor. Now, the fault in this circuit is so difficult that even if you replace all the parts of the board, you still cannot fix it. Even if you replace the microcontroller, you still cannot fix it. But my 6 senses made it easy for me, and I started working again from the basics, because when I replaced this optocoupler, I understood that this fault is not here, nor is it in any other component. So what I did was reconnect the wiring again. As you can see, this is the complete wire, and I've attached about a 1 meter wire on this side, up to this point here. Then I checked this wire again. The purpose of checking it was to see whether the signal was breaking at this point. At this stage, I relied on my 6th sense. Otherwise, I could have continued doing more work on this board. I could have done more work on this board, but I felt that the fault wasn't here. It was located somewhere else. So I checked again in continuity mode and started from this point. Since this is the signal wire, I began testing it from here all the way up to this point. There was perfect continuity. Then I thought, let's check this wire as well to see whether continuity is reaching up to this point or not. Take a look. So this also had continuity. Then I thought, since it's joined here, there could be a fault at this point. So what I did was check this indoor red wire. When I connected it, you can see there's continuity here as well. Now, its continuity is present up to this point. The next question was, does this continuity also exist inside the board or not? So I checked it again. Let me flip the board over and from here. Then we came to the back side. After coming to the back, I checked this trace. From here, I again placed the probe on the same indoor point, and the continuity was perfectly fine. If you follow this, you can see this is a single trace going in this direction. It comes up to here, and then it goes further inside. So I checked at this point to see whether continuity was present or not. Again, I connected the indoor side, the red wire point, and here the continuity was actually disconnected. Then what I did was switch to ohms mode, and when I examined this trace closely, I noticed that it was slightly damaged at this point. At one point, this trace was slightly damaged. I think maybe water got on it, or it was damaged for some other reason. Then I placed the probe here and checked this trace. It's roughly around 2 to 3 inches long, not even a full 2 inches. And when I tested it, look at the value. It was showing around 4.44 megaohms. For such a small trace, that's an extremely high resistance. Again, I checked, and it showed about 4.38 megaohms. This clearly means that when a trace gets damaged, its resistance increases like this. Now I'm going to fully clean this trace. I think it's disconnected from here, or there's some issue at this point. It really looks like something has happened here. As you can see, there's a white mark on this spot. Most likely some chemical spilled here, or water, maybe dirty water or some liquid, got on it. Because of that, this trace has been damaged and has developed very high resistance, extremely high resistance. And if you look closely underneath, the trace isn't even properly present anymore. It seems like the trace has actually been eaten away from inside. Faults like this are very difficult to find because it doesn't usually come to mind that something like this could even happen. Now you can see, from this point to this point, the trace is damaged. Let's check it once again. So, you can see now, it's showing around 0.1 ohms, which is perfectly fine. Now we power the PCB again. After applying power, we'll check on the same optocoupler that we replaced earlier to see whether signals are being generated or not. As you can see, the signal is coming and going. It's a bit unstable, so it needs a little more fine checking. At this moment, the signal is appearing at the output and then disappearing. And now it has started showing error 19. This means that when the compressor is not running, this error appears. So now the system has started displaying this error. Now, these are the normal connectors and wires. If we check the communication on them, you can see the voltage here. It appears to be fluctuating or breaking. Notice this. It drops from around 15 volts to 5 volts, then pauses, then again rises to 5 volts. You can see it's fluctuating in an intermittent manner. Now for the final test, I'm going to power it on. We'll wait for a short while. And now you can see the indoor fan has started. And look at this. The compressor has also started. It has started properly. And is running fine. Now we won't run it for too long because... So you can see... Everything is now working perfectly. But we'll turn it off because the heatsink isn't installed. So we'll shut it down, and if it doesn't stop, we'll disconnect the power directly so the IPM doesn't heat up. If it overheats, then we'll have to work on the PCB again.
Click on the left or right thumbnail to watch our next videos, and subscribe. Thank you.